So we're going to look quickly in this video at what we're going to call touching circles. So circles can either touch externally or internally. So this is an example of circles that are internally touching. So there's a big blue one and then you have a red one inside that, and they're touching at one single point, and that's inside the circle, right? Or else you can have externally touching circles with two circles that are outside of each other, and they touch at one single point, and that's called external touching. All right, so this one here is internal, and that one there on the right is external. Okay, so the idea is, if you want to find out if circles are internally or externally touching, you have to look at the distance between their center points. So in this case here, we have this one center point is here, and then the second center point is this red dot here, and the distance between those center points is equal to d. Okay, so I'm going to write that down. So I'll write distance, that's supposed to be CE, distance between center points, that's going to be equal to d, and in this case d is going to be equal to, and this is the important thing you have to remember now, that d is equal to or2 minus or1, right? Where or2 and or1 are the radiuses of each circle, and this is going to be the same here, except in this case d is going to be or2 plus or1. So if you want to prove that circles are internally or externally touching, you have to find the distance between the two center points. So you're probably going to use the distance formula for that, and then you have to find radius 1, radius 2, and you have to take them away. And if the distance between the center points is the same as or2 minus or1, that means they're internally touching. And the same here, if you want to prove they're externally touching, you have to find the distance between the two center points, and then you add the two radiuses together, and if or2 plus or1 is equal to the distance between the center points, that means they are externally touching. Alright, so that's what you have to prove if they ask you, are the circles internally or externally touching? Alright, so we're going to give one example here, and we're going to see how we can do that in a good example. So here we have our question here. It's asking us, are the following circles touching externally or internally? So we have our circle x squared plus y squared minus 2x minus 15 is equal to 0, and x squared plus y squared minus 14x minus 16y plus 77 is equal to 0. So remember, if we want to find this, we need to find 1, the distance between the center points, d, and then we need to find the radius of circle 2 and the radius of circle 1, and then we have to check against these two cases. So the first thing I'm going to do is going to find the center point of each circle. So remember, in this case, the number before the x, it's going to be 2g. So in this case, 2g is equal to minus 2. That means g is equal to minus 1. And in this case, 2f, there is no 2f, so it's going to be equal to 0, and that f is equal to 0. So the center point, so I'll say c, is equal to minus g and minus f. So in this case, it's going to be 1 and 0, because minus 1 will be plus 1. Okay, the center point for this circle here. So here we have that 2g is equal to minus 2, and we have 2f is equal to minus 16. So 2g is equal to minus 14. My mistake. I don't know why I said 2 there. 2g is equal to minus 14. That means g is equal to minus 7. Box around that. And that means we have f is equal to minus 8. So the center point of this circle, C, again is minus g minus f. So in this case it's going to be plus 7 and plus 8, because again, minus minus. So those are the two center points. I'm also going to get the radius just while I'm here. So remember, the radius of a circle is, so I'll say or is equal to g squared plus f squared minus c. So that means in this case we have or is equal to g squared is just 1 squared plus 0 squared minus 15, because in this case c is minus 15. So that means or is equal to 1 plus 15, and or is equal to the square root of 16, and that means that or is equal to 4. Okay, so that's the important things about this circle here. We have the center point is 1, 0, and the radius is equal to 4. I'll do that quickly on this side as well. So we have or is equal to the square root of g squared plus f squared minus c. So that means in this case we have that or is equal to the square root of minus 7 squared plus minus 8 squared, and it's going to be minus 77, because that's c in this case. So or is going to be equal to the square root of 49 plus 64 minus 77. So you're going to put all of those together. You're going to find that or is equal to the square root of 100. Sorry, no, not 100. The square root of 36. So it's going to be the square root of 36. And that means that or is going to be equal to 6. Okay, so the radius is 6. And the center point of this circle is 7, 8. So now we have to look at the distance between the two center points. And after that, we can tell if they're touching externally or internally. So I will go down here. I'm going to go in white. So I'm going to say D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So I'm going to call this x1 and this y1, and this is going to be x2 and this is going to be y2. Alright, so that means our D is going to be equal to x2 is going to be 7 minus x1 is minus 1 squared plus y2 is going to be 8 minus y1 is going to be 0 squared. So that means that D is equal to the square root of 6 squared plus 8 squared, and that's equal to square root of 36 plus 64. It's equal to the square root of 100. So then I'll just scribble over here. We have D is equal to the square root of 100. That means D is equal to 10. And if we look at the two radiuses, or is equal to 4 and or is equal to 6, we see that or1 plus or2, that's going to be 6 plus 4, which is 10. So that means our final thing we're going to have is that D is equal to or1 plus or2. So what does that mean? We go back up, and that means that they are touching externally. Because we see here that the distance between the two center points, D, is equal to or2 plus or1, radius 1 plus radius 2. So that's all there really is about circles that are touching externally and internally. You just have to either learn these off or else kind of be able to prove them yourself. Just draw two sketches and understand it. And that's how to prove if circles are touching externally or internally. Just get the distance between the two center points, get the two radius of the two circle, and then you have to look if it fits either of these formulas there. Okay, so that's all for now. In the next video, we are going to be looking at circles and the axes. It's kind of the last little topic inside coordinate geometry of the circle. So we'll see you then. Don't forget to like and subscribe if you find the videos helpful.